here are a couple of vocabulary words you're going to hear a lot throughout our combining like terms / simplifying expressions couple of lessons. So the first one is a monomial. So monomial, if you think of the root of the word mono, one, a monomial is a number, a variable, or the product that means multiplication of a number and variable or variables. So if you look at the examples, it's 3 because it's a number, 3x because it's the product of a number and a variable, 3x squared, 3xy, those are numbers and products of numbers and variables. X by itself is a monomial. It's an algebraic expression that you see just one term. And when we say term, we mean you don't see a plus, you don't see a minus. There are not two things that you can say, oh, I see 5x and 8. 5x plus 8. That's not a monomial. 5x itself is a monomial and 8 itself is a monomial, but together they're not monomials. They are binomials, two terms. The one thing that you have to remember is monomials can't have negative or fractions as exponents. So this basically means that there can't be a variable in the denominator. So 1 over x isn't a monomial. It's a nothingnonial. Like you can't classify it as that. And then a number or a variable under a radical. So like the square root of x would not be a monomial. The square root of 4, which can be simplified to 2, would be a monomial after you simplified it. But if you don't know what that radical, if you don't know what that number is simplified, then it's not a monomial. So variables under a radical, you don't know what that variable is, therefore it's not a monomial. So when we talk about binomial, bi means two. It's an algebraic expression with two terms. So you see 1 plus or 1 minus and two terms on either side. These terms will not be like terms because if they were like terms, you'd be able to simplify them. 3x plus 4x, 7x, that's a monomial. 7x is a monomial. 3x plus 16, on the other hand, that's a binomial because 3x and 16 do not have the same variable and exponent combination. They cannot be simplified. 3x plus 16 is as simplified as that algebraic expression goes. Two terms, binomial. 4x plus 2y, same situation. They're not the same variable exponent combination. They cannot be combined. Therefore, 4x plus 2y is a binomial that is fully simplified. When we talk about like terms, they're terms that have the same variable raised to the same exponent. So that means that 3x and 10x, same variable x. The only thing different about them is the coefficient. So 3x and 10x can be put together to be 13x if it was added, and negative 7x if it was subtracted. The only thing different about like terms is the coefficients. Everything else about them is exactly the same variable and exponent together as a pair. 3 and 10, those are just plain numbers. They are like terms. You can add them together. You've been doing it since you were a wee bit of a thing, 13. Non-examples of that is 10 and 3x. They are not like terms. You cannot put them together, add or subtract. You can multiply them, different story. You cannot add them, you cannot subtract them. They are not like terms. 10x squared and 3x, they have the same variable, not the same exponent. You cannot add or subtract them. So here are examples of combining like terms. There are terms, algebraic expressions with different pairs or combinations of like terms. Remember, like terms are variable exponent combinations, so they have to have the same variable and the same exponent. They do not have to have the same coefficient as the number in front of x. So for this, I box and circle to identify the pairs of like terms. So I have 3x minus 2x, and then I have 4y minus 6y. So 3x minus 2x is x, or 1x, and 4y minus 6y is negative 2y. So I'm going to go ahead and put those two together. X minus 2y. You could also have negative 2y plus x. And remember that you can always have a coefficient of 1 in front of any variable that doesn't have a coefficient. So if I go on to example 2, 4 minus 5x minus 7 minus 6x. I'm going to circle the like terms for one pair, 4 minus 7. I'm going to box the other pair, negative 5x minus 6x, and 4 minus 7 is negative 3. Negative 5x minus 6x is negative 11x, and I can put them in any order, just making sure that the sign, is in front of the number. So it could be 11x minus 3 or 3 minus 11x, however you want to write it. In standard algebra, the variable x comes before the variable y, and all variables come before constants, which are also numbers. Also, an x squared will come before an x, a y squared will come before a y. So for this next one, what you have to recognize is 4x is a like term with negative 10x, but positive 5x squared and negative 12x squared are like terms with each other. So 4x minus 10x is one set of like terms, and positive 5x squared and negative 12x squared are also like terms. So 4x minus 10x is negative 6x. 5x squared minus 12x squared is negative 7x squared. So I'm going to put the negative 7x squared first, minus 6x. But please know that negative 6x minus 7x squared is also an equivalent simplification of these algebraic expressions. Now have two different variables and a constant, so you're going to have three different pairs of like terms. So you're going to go ahead and combine the things that are the same, terms that are the same. So that would be 5x minus 8x, which should give you negative 3x. You have a negative 6 and a negative 10, which gives you negative 16. And then you have a plus 4y and a plus 7y, which gives you a positive 11. And I just put the positive there so I know that when I write out my simplification, negative 3x, that the sign that goes between the x and the 11y is going to be positive, or a plus sign, because that 11y is a positive number. So that's the traditional way to write it, x before y before number. But equivalent expressions would be any combination where the number, the term, and the sign in front of the term are in any order. So I'm just going to write a few different equivalent expressions. This one is my favorite because it's by math standards. X first, y second, constant third, x squared before x, y squared before y,